Okay, so most people have a little trouble with this. Some are pretty close. Okay, so if we have x plus 4 times whatever, that means it's x plus 4 times this, and x plus 4 times this, and x plus 4 times this. Okay, so we write x plus 4, and just a little more. Okay. That's a distributive law. You multiply something by a bunch of things that are added and subtracted, you got to multiply that thing by each one. That's it. And there's a picture that most people like to draw. Most people get a little confused on that picture when you get into bigger polynomials. And we'll see how it works, but it's really the same. It doesn't matter what's inside of here. Whatever's inside of here multiplies this, and it multiplies this, and it multiplies this. Okay, now x plus 4 times x squared. What's that? Well, that's x cubed, because x times x squared is x cubed, plus 4x. You're going to multiply that, but 4x squared, sorry. Okay. Because again, it's a distributive law. This plus this times this is this times this, plus this times this. Now, then we do x plus 4 times 5x. X times 5x is 5x squared. 4 times 5x is 20x. X plus 4 times 9. X times 9 is 9x. And 4 times 9 is 36. Just to keep track of where everything comes from. This sum here becomes this. Or this product, and this product here becomes this sum. Okay. And that's the first step. So what I want you to do is now write out the first step. Well, this is the first step. This is the second step. See if you can write out both steps for this. Do it exactly the same way I did. You want to group it. You want to do all this times this, times this. Okay. Once you get the hang of it, it's really pretty easy, even though it gets messy, and there are a lot of opportunities to make a mistake. Okay. So it's kind of hard to get through one of these without making a mistake, but you want to see the overall distributive law. Then you can deal with your mistakes. Okay. If you make any, hopefully you don't. Okay. Well, what I'm saying looks good now. Okay. You have to remember this step. This times this, this times this, this times this. Okay. There's another way to do it, of course. You can do this times this, and this times this, and this times this. It works either way. And sometimes you want to do it the other way, and you'll see examples where it's done the other way. Right now, I'm going to kind of stick with this one. Okay, so now what do you do? Well, it looks to me like we've got an x cubed. There's only one of them. Okay, so that's x cubed. And I'm going to rearrange this. I've got 4x squared plus 5x squared. I don't have to do much rearranging there. And actually, I've got 20x plus 9x plus 36. And I write it again because I'm going to group it a little differently. Okay, so this and this add up to Okay, 4x² and 5x² make 9x². Okay, you can't add x² terms to x³ terms, powers of x. And if they're equal for some value of x, they won't be equal for another. Whether you understand that or not, the rule is you can only combine like powers, okay? And it comes down to the distributive law, but I'm not going to use that here because I'll show you in a minute. Okay. So all you got to know is you got your x² terms, they add up. You got your x terms, they add up. And that gives you your solution. Okay. Now, sometimes you can factor this, and we're going to get into factoring. It's probably not to the point where we factor cubes. Okay. So follow that lead and see if you can complete this one. And if you have already, well, go down here and do this one, which is pretty straightforward. Okay. At least complete this one. Okay, distributive law is looking pretty good, but there's still some confusion on what we do with the numbers here. Why is it that 4x² plus 5x² gives us 9x²? Well, the way I say it, if you got 4 of something and 5 of something, that makes 9 of it, right? But if you got a negative and a positive here, one of them's positive, one of them's negative, especially if they add up to negative, that can cause a little confusion. So let me just take a note here. Okay, 4x² plus 5x² is 4 plus 5 times x². Because if you do the distributive law, it tells you I've got 4x² plus 5x², right? Okay. So we're just kind of using the distributive law backwards here. We've got this has to equal this. Everybody see that? Okay, very important to see this. Because we're going to get into factoring. That's what we need in order to do this. Okay. So if we got 4x² plus 5x², we notice we got x² in both of these. We could write the x² out here and then just a 4 plus 5. Okay. Because again, this says multiply x² by 4, which gives you 4x². Multiply x² by 5, which gives you 5x². So we're kind of going backwards in the distributive law, but it's not too hard to do in this case. And that's, of course, what the assignment was due last night, I think. Was showing you how to do. Okay. And of course, then this equals 9x². 4x² plus 5x² gives you the 9x² because of this. Okay, well, let's go ahead and I'm going to work this one out. Make sure I've got enough. Okay. So let's say we've got x² minus 5x minus 12 multiplied by x² plus 10x plus 14. Can you read that? Yeah, I better write it bigger. Because that's better. Well, the board allows you to do that. Okay, so let's try again. Okay. x² minus 5x minus 12. See that okay? Okay. Then we multiply that by x² plus 10x plus 14. And again, we're going to do what we do. We multiply this by this. Then, by this, don't skip steps, don't use superstition, go by the rules. You do enough of these, sometimes you can skip some of the rules, but I don't recommend that you skip any rules in this course. Okay, so, gonna give us this times this, and everybody's good on this step now. Make sure you stay good on it. I still didn't leave myself enough room. Okay. Go to parentheses, not 14. Make sure you got parentheses here, here, and here. Don't have parentheses, then the only thing that multiplies that x squared is a negative 12. Maybe these just out there as they are, they don't multiply the x squared. But the parentheses in the distributive law tells you multiply. Okay. Now, next step, it's probably a good idea to write out this stuff just to make sure. I'm not seeing a lot of errors in this, but I see them coming. It's x times x squared minus 5x times x squared minus 12 times x squared plus x squared times 10x minus 5x times 10x minus 12 times 10x, then x squared, so 4 times 14. Again, everybody's getting this step. Okay. Then x squared times x squared. You want to think, you don't want to just write it down without thinking about what it is. Okay, now you've got a rule that says you add the exponents. Okay, but why? Because that means x times x, and that means x times x, which gives you x times x times x times x, and that's x to the fourth. You always want to remember to think that. Otherwise, you're going to be more likely to lose track of the rule. You might or might not, but it just takes an instant to think that. And remind yourself, and pretty soon you really get used to it. That's x to the fourth. And you got an x and then an x and an x here. That gives you negative 5 times x times x times x. It's negative 5x. And then negative 12x squared. And then plus 10x cubed minus 50x squared minus 120x plus 14x squared minus 70x minus 168. And everybody's pretty much getting this stuff. Okay. So now what have we got? To write it out this way, we got x to the fourth. Then I'm going to put a blue circle around my x cubes. And negative 5 of them, and I've got 10 of them. Okay. So I'm going to write that as negative 5. X cubed plus 10x cubed. People are having a little confusion on how to add these. So I'm going to use the distributive law backwards, like I did before, just to make sure we really see the picture. You know, we got negative 12x squared and negative 50x squared and 14x squared. So that's this. And then we've got x terms. We've got negative 120x, negative 70x. And then at the end, we have our minus 168. So I recommend you do this step. Because again, we have additions and subtractions. We can group them and put them in any order we want. It's an application of what's called the commutative and associative laws of additions. But the bottom line is we can rearrange these as long as we keep the signs right. Okay. Now what do we do? Well, let's do this in detail. We got x to the fourth. Then what do we have? It's that plus 10 minus 5 x squared, right? Because 10x squared is x cubed. 10x, this multiplies out to 10x cubed minus 5x cubed. Okay. Then I'm going to write a plus here, because it's less confusing if you just always write a plus. And then put the numbers as they are in here. It's plus negative 12 minus 50. Oops, leaving off one. Then minus 14. So we get 4 somewhere. Okay. Again, this multiplies out to give me this negative 50x squared. There it is. 14x squared is there. And then color do I need? I need plus. Negative 120 minus 70x. Then we got our minus 168. That's x to the fourth. 10 minus 5 is 5. You don't have to worry about anything else. Okay. You don't have to worry about what do we get when we do this? Well, just factor out the x cubed, because that's what we call it. Factor out the x cubed, and you have 10 minus 5. Be sure that this is equal to this, because you just look at this, multiply it out, and make sure it equals this. And you got it. And then what's this? This will be plus. Now, negative 12, negative 50 is negative 62, 14 is 48. Plus a negative 48x squared. Of course, I'm going to write that as minus 48x squared. But we're going to keep all the signs here and do the final simplification to make sure we understand all the details. And then it's going to be plus a negative 190x minus 168. I'll use the blue for my x cubed here. Okay. And this gives me then, just writing it out, just going to write it all out in white now. X to the fourth plus 5x cubed minus 48 x squared is plus a negative 48, the same as minus 48. And minus 190x minus 168. Those are all the steps, and those are the steps you want to imitate. Until you get very, very comfortable with this, chances are you're not going to get all that comfortable with it in this course. So you probably ought to write out all the steps. Then you can check it. If you just let x equal 2, you see you got x squared is 4 minus 5x gives you -10, so it gives you -6. -12 is -18. And here you plug into, I'm not going to do the arithmetic because I'm saying it fast anyhow. That's -18. And if x is equal to 2, this is 4 and 20, which is 24. And 14 is 38. -18 times 38. I don't want to do that in my head. But anyhow, you get -18 times 38 up here. Okay, write that down. You can check. Okay, I'm going to forget it. I don't want to write it in the board. If I plug in 2 down here, 2 to the 4th is 16. 2 cubed is 8, and 5 times that's 40. So I've got 56, and I'm going to get -48 times 4, which is 892. And you know, this and this, I'm not going to try to keep track of the numbers. Got pretty good sleep over the weekend, so my mind is halfway there, but it doesn't want to go that far. Okay, be hard to keep all those numbers in my head and keep expanding. Okay, even if I wasn't expanding, it'd be a little hard to keep all the numbers and get it accurate. My point is, what you get if you put 2 in up here, it better be the same as what you get when you put 2 in down here. It doesn't have to be 2. You could substitute a different number like 5,386. You don't want to do that much. I don't want to do it with 2. Okay. You can check. This should come out the same as this. If I did every step right, it will. I don't guarantee I did every step right. There's a lot of arithmetic in there, a lot of simple little steps. Get a sign wrong, one addition wrong, and it's not going to work. Now on a test, if I grade this, if you show all the steps and get it wrong at the end, and a problem this long, I might not even penalize you a point if it's a really simple mistake. Really spot, simple mistake, and you've got all the steps. I'd probably give you full credit. If it's one like this, it's a little shorter, I'd probably take off a point if you just made some stupid little mistake with a sign or with a number. Okay, I'm not going to nail you on it. Even better if you write out your steps. What step did I use from here to here? I used the distributive law. If you write out distributive law next to this step, then down here, you use distributive law again. We just use distributive law in each of these products. So you write distributive law again. Okay. And then just something like, okay, change the order. Change the order, multiplications and additions. Well, actually here we just use rules of exponents along with a little bit of insight about why x squared times x squared equals x to the 4th. You don't want to keep thinking about that. You could even write out that, for example, x squared times x squared is x times x times x times x is x to the 4th. Just write that down, and I know that that's probably what you did throughout these steps. Okay. That's insurance. Even if you make a bunch of arithmetic errors here, if you tell me what the steps were and show me clearly that you're thinking correctly, I'm going to be a lot more generous with credit. Basically, I want to see the sweep of the rules. If you quote the rules, it shows me that you have something that's probably going to stick with you when you get to a pre-calculus course. This is going to need to. This is going to need to be really obvious when you're in pre-calculus. You can't be stumbling over this when you're trying to do all the stuff you do with these things in pre-calculus. Okay, so there we have it. Now, I'm not going to work this one because I think everything we did here tells you what to do with this. Okay. But let's talk about the greatest common factor now. The greatest common factor is usually GCF stands for greatest common factor. And we've got 4x cubed plus 8x squared minus 2x. Well, you know, I could write that. It's not going to be the greatest common factor, but I'm going to write it with one factor out there. Okay, I could write this as x times what? Usually. Okay, it took us a little while to really convince ourselves that what we think we ought to do is really what we ought to do. Okay, so let me write this out. Okay, you got x here, and you got to have something in here so you get all these. Well, what would you multiply x by to get 4x cubed? Well, everybody got that. You multiply it by 4x squared because x times 4x squared gives you 4x cubed. Okay. Now you got to get 8x squared. What do you multiply by x to get 8x squared? 8x. And what do you multiply by x to get negative 2x? Well, it's negative 2. I multiply this out, I get this. So I just extracted a factor. X is called a factor. Something that's multiplied by something else is a factor of what you get. Okay. Say that a little more clearly, but it wouldn't make sense. Okay. So there we have it. Now, there's even more that I could do. I can actually factor out a 2x because every one of these numbers is a multiple of 2, isn't it? So what am I going to have to put inside here if I factor out a 2x? Okay, so down here, if I have 2x out here, what do I multiply by 2x to get 4x cubed? 2. It's got to be,
Or 2x squared.
2x squared, right? This 2x times 2x squared gives us 4x cubed. 2x times what gives us 8x squared? 4. Or it'll be 4x. And 2x times what gives us negative 2x? Well, that's times negative 1. Okay. So you check at the end, and you always need to check. Always multiply this out. Multiply this out. You get this. All you're doing is reversing the distributor. Okay. Well, this factoring thing gets to be even more fun. You can write x squared plus 5x plus 6 as x plus some number times x plus another number. Okay. Now, the two numbers you have here, when you apply the distributive law, they're going to be multiplied by each other. So the two numbers you get here have to multiply out to 6, right? So there are several possibilities for the two numbers that you can put in here. Okay, like what two numbers? Give me two numbers that multiply out to 6. Don't say anything, but write down two numbers that multiply out to 6 and put them in there. Okay. Okay, well, we can easily see that those people write 2 and 3 first. That's fine, okay? And then really obvious, 1 and 6, right? Okay. Now there's two other possibilities. And only one of these possibilities is going to be right. So we'll put a question mark here. Question mark here. And only one of these, when you apply the distributive law, gives you this.
Gives you the whole equation.
Gives you this expression, because when I say equal, I mean, whatever X is, this and this have to be equal. Okay. So yes, in answer to your question. So which one is it? Got 4 possibilities. Okay, well, let's just take this. Multiply out X plus 1 times X plus 6. Use the distributive law and multiply that out. Okay, so we can try all these possibilities. Now, this one isn't going to work, but I want you to see why. Okay, so for the purposes of binomials here, we understand the distributive law well enough. We know we've got to multiply this by this, and this by this, and this by this, and this by this, right? It's okay to do that when you have binomials. I don't want to see the distributive law when you have anything else. You have to understand that this is just a distributive law. What ends up happening, everything here is multiplied by everything here. Okay? So X times X is X squared. X times 6 is 3x. 1 times X is X. And 1 times 6 is 6. Gives us X squared plus 7X plus 6. Now we notice two things. About the 1 and the 6. Where's the 7 come from? The 1 and the 6 add up to 7. Okay, why is that? Well, we have 1x and we have 6x, so we have 7x. Okay. And 1 times 6 gives us our 6. So what we end up looking for, ultimately, now we can always do this. We can always list all the possibilities. And that's a valid method for doing this, but it's shorter to look for two numbers that multiply out to 6, which is why we put two numbers. We see that we have to have two numbers here that multiply out to 6. And those two numbers would have to add up to 5, right? Well, we got 2 and 3. Do 2 and 3 multiply out to 6? They add up to 5. So that's the one we would actually pick. So let's just see how that works. X plus 2 times X plus 3 equals X squared plus 2X plus 3X plus 6. Okay. 2X plus 3X gives us our 5X because 2 and 3 add up to 5. We're going to have 2X and we're going to have 3X. That's what We wanted to add up to 5. The open math will explain that to you, but I want you to see that right now. Okay, so finding two numbers that add up to 5 and multiply out to 6, we can do this. Now, just real quickly, I'll just do another one so you have it to refer to if you want to look at the video. So I'm just going to have to say it. We're 2 minutes over. Let's say we have x squared minus x plus 6. Okay, so now we need two numbers that multiply out to -6, right? So that could be like x minus 2 and x plus 3, or x plus 2 times x minus 3, or x minus 1 times x plus 6, or x plus 1 times x minus 6. All these numbers give us a -6 out here, right? But only one of them gives us a -x. Which one would that be? Well, it's the one where the two numbers add up to -1. It's this one. Because you're going to get a -3x and a plus 2x, and that gives you a -x. So it's this one. And all the other numbers multiply out to something else. So it's not too hard to do this, especially if the arithmetic is pretty good. And open math will give you more details on it. We had to get hung up on polynomials, okay? And there's a question on this one. So I'm gonna go ahead and just add this to the video. I'm just gonna close out, do that, okay? So we're over time. We got another class to go to. Go. If you want to stick around and watch, you're welcome to. We've got another class starting in 4 minutes. I got to do kind of quickly. Okay, don't walk in front of the camera. But here we have. Okay, this is just because there was a question. We didn't have time to do this in class and have to do it quickly because we've got another class starting. But this problem here, it's actually quite simple. We have one polynomial. We add another polynomial. Well, that's just x cubed minus 5x squared plus 7x minus 3. And we're adding that to this. Well, we can remove the parentheses. It's like there's a 1 in front of this. We just create 2 and 1. It's going to be plus x to the 5th minus 4x squared plus 9. Well, let's write our powers in decreasing order. We got an x to the 5th. That's there. And then the next lower power we have is an x cubed. So we're going to add our x cubed here. So let's see, we've got our x to the 5th, got our x cubed. Then we have minus 5x squared minus 4x squared. There we have it. And we have a 7x. And we have a minus 3 plus 9. And of course, that adds up to plus 6. Now, the only terms we can combine are the -5x squared and the -4x squared. As we see, we've got x to the 5th plus x cubed minus 9x squared plus 7x plus 6. Now, people were trying to multiply these, but there's a plus between them. So we've been doing a lot of things with multiplying by the distributive law. It's natural enough to do that. You got to notice, it's got plus on there. We don't have a multiplication as we did in the other examples. So it just comes down to this, because if there's a number in front of this, a number in front of this, how you distribute it, we still have a plus here. And it's actually much simpler
How far
to multiply.
close or